All right, my next example is going to be a rectangle with a hole in it. Y in millimeters, X in millimeters. Okay, and then I've got here is my rectangle, and then I'm going to put a circle in it. And this circle is centered up at 50 and 170. And the circle has a radius of 20 millimeters. And here's my solid area. All right, I wish to find the volume of one revolution about the y-axis and the area of one revolution about the x-axis. And this time I'm going to do it in components instead of the composite body. In the last example I did composite body, so I did the whole centroid for the whole body. This one I'm going to do in two parts, the rectangle and the circle. All right, so my solution, volume is equal to theta times the sum of A, I, R bar I for my volume of revolutions. So that's going to be 2 pi for one revolution times 150 times 60. And then the distance to its centroid from the y-axis is going to be 50 plus 150 divided by 2. And then I'm going to subtract my circle. Area of the circle is pi r squared. And then the distance to its centroid from the y-axis is 170 millimeters. So my volume calculates to be 5.73 times 10 to the power of 6 millimeters cubed. Okay, this is about the y-axis. My area about the x-axis is going to be the angle of rotation times the sum of the length of the perimeter and each perimeter's centroid to the x-axis. All right, so this is going to be 2 pi. I've got the top line of my perimeter, which is 150, and the distance to its centroid to the x-axis is 80. And then my bottom line, which is 150, the distance to the x-axis is 20. Plus, I've got my two vertical lines, so 2 times 60, and their centroid is at 50. Okay, and I've got two of those, that's why I have the 2 there. Okay, that's lefty and righty. And then I have plus the perimeter of the circle, 2 pi r. And the center of the perimeter of the circle is the same as the center of the area of the circle. And that is also 50 millimeters away. Okay, why are you adding the circle? Because this is surface area. So we have the external surface area and the internal surface area. They are all positive lines. And my area of revolution about the x-axis for the surface of my shape is 171 times 10 to the third power millimeters squared. So there's one answer, and there's one answer.